Hello guys, so today in this video we'll produce Micrograd from scratch in C, and along the way I'll try to explain you how each and every function works and how you can basically make it yourself. Okay, so yeah, let's just start. So here you can see that I have an empty file, C file, okay, and here is the original Micrograd code which Karpati wrote. So we will reproduce all of this, like uh, whatever this is 105 line of code in C, and we'll just see how it works. Okay. So first thing first, to make this, we need to include the libraries which we need. Uh, so and then we'll include math library. Okay, which will have some mathematical functions. So and now we basically need two variables, like in the first part. Okay, so we'll define a struct. Okay, so struct is basically uh, it's like a class. Okay, just like you have a class in Python, where you can store multiple data types, values of multiple data types. We have a struct. Okay, so in struct we can hold and store different types of values from different data types. Like it could hold a character, or it could hold an array, or it could hold an integer or float values. Okay, so we'll define a struct over here. Sorry, scalar. And inside this we first need two values. Okay, I'm keeping the values and gradients to the float 64 because we need just for the convenience. Okay, so we have two things. Okay, data and grad. Now we need this function, which is a backward function. Okay? So how will we define the backward function? We don't have actual any function written right now. So what we will do is we will define a pointer to it. We don't have a function. It doesn't work right now. We haven't written it. So we'll just assign a memory to it, and later on when we'll have the actual values, then the function would work. Okay? So to define a pointer function, you can just search on Chrome how to define a pointer function. Okay? You can see you need to write the data type which it would return, which in case would be void, because we are not going to return anything. You can see in this we don't return anything in this function. Okay, so yeah, and we'll write the name, which is in this case is a pointer. So we'll write, and now we need a data type. What data type of value would it accept? Like what would the parameter? Okay, so it would be scalar, and would be, sorry, we have to write struct scalar. Okay, that's it. You this means actually we are going to pass on the struct, which is a scalar struct. This scalar value would be passed on to it. I'll show it later to you how it works. And we need two more variables. Okay, three more variables. First one would be uh, so you have this thing right now. So first thing is previous size. Okay, previous size is actually it it's the size of the array which will hold the previous elements. Like let's say we performed a plus b, c is equal to a plus b. Okay, so when we'll call c dot prev, it should hold a comma b. Okay, because the previous operation was a plus b. Okay, so to if we're using Python, so we can easily define any size of the variable. Okay, any size of the array. But in since we are using C, we need to allocate a memory to each of the element. So we just use previous size integer, where will we have the size of the array, and according to that we'll just uh, assign the memories. Okay, and this scalar pref struct is basically a structure that would hold scalar values, and it's pointed to the pointer. Okay, because it's actually storing a pointers, raw pointer, because a is a pointer and b is a pointer, and we have a new pointer variable which is named prev, and it would hold those pointer values. Okay, that's why it's a double pointer. We need to initialize each and every value, so we'll use a scalar pointer function. Okay, we'll have name it initialize scalars to take a value data scalar pointer. It's actually gonna accept the previous function. Like you can see, we had a children. Okay, so here we are using scalar, a double pointer scalar, which is basically gonna store it. I explained this previously. So here we are using scalar, which is a double pointer. Actually, it's gonna store these childrens, which is the previous elements that were using the operations. So here is it. We'll write children, and then we have a children size. Okay? Basically, it will define how big the array is gonna be. So yeah, so what I did here is we are basically using the scalar struct which we defined over here. Actually, I just forgot one thing. Hold on. Yeah. So basically, we defined a scalar struct, and we are using size of function, which would actually calculate the size of the whole struct, and it would allocate the memory to this new pointer. Okay. Uh, this new, and now we'll start assigning the values. Okay. So we got data. Yeah, we keep the grad 0 for now. Now we actually need a backward function, and we just need an empty backward function. We don't want to return any value for now, because each and every function would have its own backward operation. So for now, we will just create a no backward, which is no operation backward, and it won't take anything and it won't return anything. Actually, it take a value, and but it won't return anything. It won't do anything. It's just a dummy function. Okay, just like this lambda none is. Okay, so we'll do it backward, and we'll return b. Okay, and yeah, one thing, um, exp is equal to 1. Onto the first function, we have to create this addition function. Okay, so sorry, scalar add value. So first thing first, we'll create a struct there will assign the children's, which are basically the previous elements. Okay, so first thing first we'll do that. So here what we did is we created a pointer variable to a pointer which should store these are scalar pointers. Okay, so what we have is these pointer values which are being passed into this function. Okay, so we are taking we are just measuring the size of it and we're multiplying it by 2 and allocating a new memory to a new pointer variable. Okay, uh, that is that's why we are using double pointer, because this is a pointer variable and we are allocating that size of memory 2 times the size of memory to a new pointer variable which is storing those pointer values. Okay, so basically it children has uh, two of the values, scalar values is being stored over there. So now whenever you will check it, the addition function, it would have this a and b values. Okay, so in previous, so, okay, so here what we have done is uh, we are taking the data part of the A struct, which is self.data, you can see over here, and then data part of the B, which is other dot data, and we're adding them and we're passing to this initialized scalar. Okay, and we have this scalar children. Okay, so we have created a double pointer, which is this children, and we're passing to this part. Okay, and we children size it needed, which was 2. This will define the previous size, and that's how we're doing it. Now we will return out. Now we have to create the backward function for this, which is pretty simple. Since it won't return anything, we'll keep it void, um, and backward. So we took out those two previous elements from the uh, this out variable, because we are passing this into this, and we are taking out the previous elements. Since we know there are two elements, so we did it 2 times and we are storing them into a new pointer variable. And now what we'll do is we'll just create the variance. Okay, for that, sorry, not for B, actually for A. And same goes for this. So it's pretty basic how we did it. So now in similar manner, we'll create a multiplication function and a multiplication backward function. Okay. Okay. So we have now our multiplication function and multiplication backward function written, and we just followed the same exact thing steps what we did for addition. So yeah, you can see we are taking out the data of the A scalar and we are multiplying it with the B scalar. Okay, and we are passing the children's and then to the size of the children. So yeah, now we have to write now we have to write a power function, and then one of the uh, activation functions. Okay, so yeah, just write it. So now here you can see we created this time. We have given size of 1 only, because we need just one scalar uh, value this time. because children will have just the previous size of 1 because we have just one element previous. Okay, so here we are passing this power.data. You can see here we are using the mathematical power function, which is in math.h library. Okay, so yeah, and here you can see we updated the exponent parameter of the this variable, this new scalar, because if we didn't do that, we won't be able to calculate that uh, gradients. Okay, so that's how we are doing. Okay, so and now I have to write the ReLU function, and maybe I'll write a tanh function too. So you can see I wrote the ReLU function, and in similar to the power function, we are using a single size of uh, single children size, because we only have one value, one previous value on which would be applying the operations. Basically, a simple backup function of ReLU. If you have a data point greater than 0, will return just 1, and if not, then 0. Okay? So yeah, and we can test this out, but let me write this negative and subtraction functions. Okay, which is important, by the way. So in negative function, what we are doing is actually we're multiplying the uh, previous value. Like I want to negate 2. Okay, we have a value named scalar storing value is equal to 2. Okay, and now we want to negate it, so it would go into this negative function, and what will it will do is it just multiply it by -1. Okay, so what it would be doing is calling two of the backup functions consecutively. First one would be the addition, and then it would call multiplication. Okay, so yeah. Uh, Here's how we are going to test these functions out. Uh, but first, let me write a print function. Let me write a uh, print function really quick, which would be just like a wrapper function to show these values. Okay, so here it is. Okay, and now we'll just print those values. C. Okay. Let me run this. Okay, so we are getting some errors. Let me just quickly fix it. See? Okay, so uh, problem is this was the problem. Okay, I wrote values and then called it with the wrong name. Okay, you can see we are getting the answers correctly. Which is, you add 2 and 5, you'll get 7. If you multiply them, you get 10, and if you raise 5 to the power 3, sorry, you raise 10 to the power of 3, you get 1000. Okay, so yeah, works. Now we need to write a backward function, which is like this backward function, which will create a topo, which is basically an array holding the scalar values, and a visited set, which is also an array holding the scalar values, and we'll create a topographical map, and we'll just uh, loop through them and call the backup function on each of the values. Okay, so yeah, let me just create it. Really. Okay, so we have created the backup functions. You can see. Uh, so actually, what we do is we have this. So what we do is first thing first, since we are creating two new arrays, one is topo and one is visited. So we need to define the size of them, like how big it would be. Okay, so we have to have new variables like topo size and visited size, which would be helpful to assign the size of those arrays to the memory. and right now you can see here. So yeah, so now this line creates the pointer arrays. Okay, so what we are doing is we have a scalar pointer, are these values. Okay, so we are going to store those values into a new array, which basically would be a pointer array. Actually it would, because it's storing those pointers, which are memory addresses. Okay, so what we are doing is, basically we are creating an array which will be holding the scalar values, which basically are pointers. So the array would be pointer array, and yeah, so and we are keeping the size 100. I'm assuming the maximum number of operations will be using would be 100. So yeah, it could be more, it could be less. You can adjust it according to yourself. And now we have this build topo, which is calling this functions. Okay, here you can see we have passed down the memory addresses of each variable, because we are using those pointers. Okay, so yeah, and what it does is actually, we have this topo, which is basically storing a bunch of scalar values. Okay, so uh, first we have a scalar value that storing another two previous values, uh, or maybe a value, and which will have another two previous values, and so on and so forth. Okay, so that's it. So what we need to do is, we'll loop through the topo, and we'll pick up the first value. Okay, and we'll check the previous values if there are in that, which in this case should be. And what we'll do is we'll use those previous values and we'll call a backward function on them. Okay, and once we call the backward function, the gradients would automatically update according to each of the backward function that's been present over there. So that same thing we are doing in this case. Okay, just remove that. So yeah, the first thing we do is we pick out the scalar value, the first scalar value, and then we check, we recurse it in same function again, and we just keep recursing it until we reach the last value. Okay, and soon as we do this, we create a new, we update the topographic, we update the topos. uh, Now what we do is we'll reverse the topo, and we'll keep updating gradients like this. So suppose this is the last value. Okay, actually scalar. Okay, because each previous contains two scalars, maximum two scalars. Okay, so this is the last scalar value. Now what topo would look like is first scalar value over here, then that previous, and then according that previous, and then that previous, and then at last this. Okay, so now we'll reverse it. This whole topo will reverse it, and this value will be our first value, and we'll start calling the backup function on it. Okay, so first will be our gradient, last value. This has a gradient 1, which we assigned it, and we'll call this values uh, at this position. We call the backward function, and the new value would be the new gradients would be updated, and it will keep updating till it reaches the last scalar, which is this scalar. Okay, so hope you can understand it. So that's it. And yeah, and at last we just free the topo and visited arrays from the memory. I hope you found this useful. and I'll keep recording more tutorials in future. This was my first one, and I hope I'll keep recording more if I don't procrastinate. Uh, and please, if you like the content and if you want to check out my projects, you can just I have provided links in the description, and you can check them out. I've created lots of projects like small language model, and you can just check out the GitHub. Okay, and yeah, I'm creating PyTorch from scratch. If you want a tutorial for that, you can just comment in the comment section, and I'll see if I want to make it or not. Yeah.